All right, welcome back to episode 2 of physical dimension. In our last class, we introduced physical dimension and then we solved physical dimension for four um, quantities. We solved for area, we solved for volume, we solved for speed, and we solved for acceleration. Now we are there on force. Okay, so we said force is mass and acceleration. Mass is a physical dimension. We drop it down. So we have there. Then acceleration is not a physical dimension. It's not among these three. We bring it out with the formula speed divided by time. Please take note, speed and velocity, they are the same thing. I'm just using speed in this case. I could use velocity. So speed divided by time. If you observe carefully, time is a physical dimension, but speed is not. So my mass will remain untouched times my speed, which is what it's not among the physical dimension. I'll bring out the formula, which is what? Distance divided by time. This is for speed. Then I also have in front divided by time. This is divided by time. Are you seeing clearly? Mass is there. This first initial divided by time is there. Then speed itself is distance divided by time. Now look closely. Mass is among the physical dimension, number one. Distance is among the physical dimension, number two. Time and time, they are among physical dimension, number three. So I'm going to change them now. My mass is going to be capital M. My distance is capital L divided by my T, capital T, divided by my T, capital T. So the way I'm solving it like this on a straight line, it makes it easier. So in mathematics, we actually change division to multiplication with the term after it to turn upside down. So if this is T over 1. T on its own is actually T over 1. So turn upside down, you have 1 over T. Change division to multiplication, it becomes 1 over T. Going on further, we have M times L, which is ML times 1 times 1 is 1. Okay. Over T times T is T square. I think we are done with this now. So we have ML 1 over T square from a negative index law becomes what? T raised to power minus 2. So this is the physical dimension for what? For force. That is the physical dimension for force. Going on further, we are going to solve physical dimension for density. Density, that should be number. What's the formula for density? Density is actually mass divided by volume. So mass divided by volume. Mass, if you look closely, is one of the physical dimension here, but volume is not. We had solved volume before in our first episode. Now we are going to ignore as though we've solved it because it's a fresh work in exam. You're not going to be cramming many things. We just know a principle and then you solve it afresh and you are done. I'm going to bring out the formula for volume. So mass written here divided by my volume is length times breadth times height. Length times breadth times height. So I have my mass as capital letter M. Alright. Then length and breadth and height is actually L times L times L. Please, at this point, do not change this to multiplication yet. Work these guys finish before you can now change this to multiplication. So we're going to have, because if you change the multiplication now, it's going to affect only this one guy, but as it's supposed to divide by the whole volume. Mass divided by L times L times L is L cubed. So now I can change it times 1 over L cubed. So negative index rule, you have 1 over L cube as L raised to power minus 3. So this is that for that. I believe you understand. If you have a question, drop it in the comments section. We are going all the way to about 15 physical dimensions because we want to make sure everyone is understands this. Then number 7. So right now we have done what is the formula for momentum? Momentum is actually mass times velocity. Mass times velocity. Like we had said, velocity and speed is the same thing. So though at some special teachings in vector and scalars, we are going to differentiate velocity and speed. But then for the formula, they're actually trying to be the same. Mass is a physical dimension, so we are writing it down there. Then velocity is not. So I'm going to put the formula for velocity, which is distance divided by time. When we differentiate velocity from speed, it's actually velocity is displacement over time. Okay, but displacement and distance, they are the same thing for physical dimension. So that's why I'm not bothered by it. But follow along. Mass times distance over time. Okay, we've done that. Now we're going to change it. What is mass? Mass is actually m times distance is what? L divided by t. So I have ml times 1 over t. And then go further, your 1 over t becomes what? T raised to power minus 1 from your negative index law. So I'm going to solve impulse side by side so that I'll show you something. What is the formula for impulse? Impulse is force times time. Force multiplied by time gives you impulse. Now, force is not a physical dimension there, but time is a physical dimension. So I'm going to bring out the formula for force, which is mass times acceleration. Mass and acceleration is for force, then times the time that was initially there. So this is this there. Notice carefully also, mass is a physical dimension, but acceleration is not. So I need to open up. Acceleration. I need to open up acceleration. This needs to be dealt with. So mass, I'm going to bring out mass now. Mass times what is my formula for acceleration? Speed over time. Okay, I can still write velocity at this point. Velocity over time is my formula for acceleration. Then times this time we have here. Please take notes. This mass I have here, this is it. This time I have here, this is it. This velocity divided by time is what I have as acceleration. These guys that are physical dimensions already, don't touch it, just keep writing it down until we get to the point where everybody's okay. Then we can now convert everybody at once. Notice velocity is not a physical dimension, so I need to still break down velocity. So I'm going to be having mass times what's velocity? Distance divided by time. This is for velocity. Okay, now this is for velocity. Velocity is distance divided by time. Then this divided by time here now is going to come down, divided by time, then times time. Observe what I'm just doing now. It's getting longer and longer. Force times time is the formula for impulse. Force is mass times acceleration. This other times time is there. And it has come down and come down. So that's why we have that mass came down and came down. Acceleration became velocity divided by time. Velocity became distance over time. This divided by time initially there is here. Now look at it, everybody is in the same physical quantity. So we can now change. So that mass is what? M times distance is what? L divided by time is what? T divided by time is what? T times time is what? T. So having them to be the same now, I'm going to have M times L, which is ML. Division becomes multiplication, so times 1 over T. Division becomes multiplication times 1 over T. And this one is already times T. If you look closely now, this T can divide the other T up. This T can divide this T up. It's gone. So what I'm left with now is what? ML. ML from here times 1 over T. So ML times 1 over T, which gives me ML. What is 1 over T? T raised to the power minus 1. I solved this at this point on the same board where I saw momentum, just to show you that the dimension of momentum is the same thing with the dimension of what? Impulse. That is why we say impulse and momentum, they have the same quantity. So in our next class, we are going to continue in our episode.